myself Dr. Ashok Babu, working as Professor and Head EC Department. So in this video, I am going to discuss about some problems in magnetostatics. So first of all, let's see the one problem. So here the conducting triangular loop in figure carries a current of 10 amperes. Find a magnetic field at 0, 0, 5 due to side 1 of the given loop. So here due to the side 1 of the given loop, we need to find out the magnetic field intensity. So here let us assume this one. So here in this one, the distance is along this one is distance is 2. So it is the distance of 5. So if you find out the hypotenuse, it is 5 square plus 2 square is root of 25 plus 4, it is root 29. If you find out the cos of the angle, therefore it is cos alpha 2. Cos alpha 2 equal to, it is 2 by root 29, and sin alpha 2 is equal to, here we can have 5 by root 29. So we'll do the problem. So here we need to find out that to find the magnetic field at 0, 0, 5 due to side 1 of the loop in figure A. So we need to consider the figure B. So where side 1 is treated as a straight conductor. Therefore, from the figure we can have cos alpha 1 equal to cos 90 degrees. So it is cos alpha 1 equal to, it is 90 degrees. So or it is 90 degrees. Therefore, cos alpha 1 equal to 90 degrees, and which is equal to 0. Cos alpha 2 equal to 2 by root 29 from the figure. Cos alpha 2 equal to 2 by root 29 from the figure. And rho is given as 5. And here I am assuming A5 equal to AX AZ. AX AZ equal to minus AY. Because we know that AX in rectangular coordinate system we have X comma Y comma Z. Therefore AX cross AY equal to AZ. AY cross AZ equal to AX AY equal to AZ. AY AZ equal to AX, and AZ cross AX equal to AY. So because here we are assuming AX cross AZ. So AX cross AZ equal to, we can assume minus AY. So according to Biot-Savart's law, the magnetic field intensity is H equal to I by 4 pi rho into cos alpha 2 minus cos alpha 1 into A5. So in place of A5, here I am assuming minus AY. Therefore, if you substitute the cos alpha 2 value, cos alpha 2 is I equal to current is given as 10 amps. 10 amps by 4 pi into rho is given as 5 into cos alpha 2 is 2 by root 29 minus 0 into minus AY. Therefore, the magnetic field is along the y direction is minus 59.1 AY milliamps per meter. Next, we need to find out the second problem. Find the magnetic field intensity at minus 3, 4, 0. So due to the current filament shown in figure. So here we need to find out the magnetic field at minus 3, 4, 0. So using the two field intensities, that is H1 and H2, where H1 and H2 are the continuous to the magnetic field intensity at P minus 3, 4, 0. So due to the portion of the filament along X and Z respectively. Because the total filament is placed along this is the x-axis, this is the z-axis. So we need to find out the magnetic field intensity along z direction and the magnetic field intensity along the x direction. The total magnetic field intensity equal to the field intensity along z direction and the field intensity along the x direction. Along y direction, the field intensity is 0. Therefore, the total magnetic field intensity H equal to H1 plus H2. So we know that the magnetic using the Biot-Savart's law, the magnetic field intensity H2 is equal to this I by 4 pi rho into cos alpha 2 minus cos alpha 1 into A5, and the point P is given as minus 3, 4, 0. And if you find the distance from the figure, so it is 3 and it is 4. The distances are 4. If you find the 3 and 4, root of 3 square plus 4 square, it is root of 25, it is 5. Therefore, from that we can find the alpha 1 and alpha 2 values. So from the figure, alpha 1 is, so it is alpha 1 equal to 90 degrees. Alpha 1 is 90 degrees, and alpha 2, we need to find out the alpha 2 value. Alpha 2 values here is 0. Alpha 2 equal to 0. So therefore, if you substitute these two, we can find out the H2. So here A5 is obtained as a unit vector along the circular path through P on a plane z equal to 0. So here the direction can be determined using the right hand screw rule. Therefore, we can write the a phi. A phi can be expressed as a phi is equal to sin theta ax plus cos theta ay. Sin theta ax plus cos theta ay. So from figure, sin theta equal to 4 by 5 and cos theta equal to 3 by 5. Therefore, 4 by 5 ax plus 3 by 5 ay. Therefore, 4ax plus 3ay by 5. A phi value is 4ax plus 3ay by 5. And if you substitute in the expression, H2 equal to, the current is given as I equal to 3 amps. 3 amps by 3 by 4 pi into rho is 5 into cos alpha 2 is 0 and cos alpha 1 is 90 degrees. Therefore, 1 minus 0 into 4ax plus 3ay by 5. Therefore, the magnetic field intensity along the z direction is, it is 32.2 ax plus 28.65 a by milliamps per meter. So, this is a magnetic field along the x direction. Similarly, we can find the magnetic field here in place of a phi. Directly we can assume minus in place of 4ax plus 3ay by 5, we can assume minus a phi, where the direction of phi is can be determined by using the right hand screw rule. Therefore, if we directly assume a phi in place of x comma y, so the value is minus 47.75 a phi milliamps per meter. Now we need to find out the magnetic field intensity H1. So here, similarly, we can find the magnetic field intensity at point P. So where rho is equal to 4 is given as rho equal to 4 and cos alpha 1 is given as 3 by 5 and alpha 2 is 0 degrees. Same as the previous one, alpha 2 equal to 0 degrees and alpha 1 equal to 3 by 5. And if you substitute same values in the expression, then it is H1 is equal to 3 by I by 4 pi rho. I is 3, 4 pi rho is rho value is 4. The distance is 4. The distance is 4 into 1 minus 3 by 5. It is cos 0 minus cos alpha 1 is 3 by 5. 1 minus 3 by 5 into Az. So if you simplify this expression, 23.88 Az milliamps per meters. So the total magnetic field intensity is equal to H equal to H1 plus H rho. So it is the total magnetic field intensity. Next one, a circular loop located on x square plus y square equal to 9 and where z equal to 0 carries a direct current of 10 amps along phi, along a phi, where a phi is a unit vector. So here determine H at 0, 0, 4 and 0, 0, minus 4. So we need to find out the electric field, magnetic field intensity along 0, 0, 4 and 0, 0, minus 4, because these two points are exactly opposite to each other. So one point is 0, 0, minus 4, another one is 0, 0, 4. One is in positive quadrant, another one is in the negative quadrant. So here we need to find out the magnetic field intensity. So here we need to assume the circular current loop. So assume the circular current loop which is having the radius rho and which is having the current element ideal and which is placed along the z-axis. And the height of the point is, here we need to find out the point P. We need to find out the magnetic field intensity at point P. So the point P is 0, 0, H. The height of the magnetic field is, the point P is H. So to find out that, we have the, according to Biot-Savart's law, we have the problem, we have the formula dH equal to ideal cross R by 4 pi R cube, where R is a vector. So here dl equal to, we can write that because it is a circle, we can assume dl equal to rho d phi into a phi, rho d phi into a phi. And we need to find out the distance between the 2 points. So one is 0, 0, H, another one is x, y, 0, because the total magnetic field is line is based along the z-axis. So it is 0. Therefore 0, 0, H minus x, y, 0. So if you find out the distance between these two, it is 0 minus x ax, then plus 0 minus y into ay plus h into az. So minus xax minus y ay plus haz. So minus of xax plus yay plus haz. So in place of xax plus yay, here I am writing rho arrow, because we know that rho is equal to root of x square plus y square. So in place of row, we can write, in place of x comma y, we can write the row value. Therefore, minus row into a row plus HAZ plus HAZ. Then, so here we need to find out the DL cross R. So DL cross R can be estimated as is a row A5 by using the det of the determinant matrix, det of the matrix. So a row A5 AZ. In cylindrical coordinate system, we have rho comma 5 comma Z. Therefore, a row A5 AZ, and along the particular phi direction we have rho into d phi. Along phi direction we have rho into phi. Therefore, 0 comma rho d phi 0, and along the here we have along rho direction we have minus rho, and along phi direction we have 0 here, and along z direction we have h. So if you find out the det of this matrix, so it is a row in first one is a row into it is 0 minus h into rho into d phi minus 0 minus h minus 0 h into rho d phi minus 0. Here it is minus a phi into minus a phi into, so it is 0 comma 0 0, and the third one is az into we have again 0 minus z, therefore minus plus rho square d phi. Therefore we have rho into h into d phi into a row plus rho square d phi az. So if you substitute the same in dh, we have dh equal to, in place of I by 4 pi into dl cross r. dl cross r is, so dl cross r equal to rho h into d phi into a row plus rho square into d phi into az, by, if you find the magnitude of the distance, so it is root of rho square plus h square whole power 3 by 2. So according to the symmetry, we can substitute a row equal to 0. So if you substitute a row equal to 0, this one becomes 0. Then the equation is dh equal to I by 4 pi into rho square plus h square whole power 3 by 2 into rho square into d phi into az, or in I into rho square into d phi into az by 4 pi into rho square plus h square whole power 3 by 2. So we need to integrate the equation between 0 to 2 pi because we have d phi. Therefore, if we integrate the expression, so here I is given common, I into rho square by 4 pi into rho square plus h square whole power 3 by 2 into 1 into d phi between 0 to 2 pi. So if you integrate this, we have 2 pi. For I is equal to rho square into 2 pi by I into rho square into 2 pi by 4 pi into rho square plus h square whole power 3 by 2. So 2 pi cancel each other. Therefore, we have magnetic field H is equal to I into rho square into Az by 2 into rho square plus h square whole power 3 by 2. Now we need to substitute the current value, rho value, h value. So here current I is given as 10 amps, rho is given 3, and h equal height equal to 4. So if you substitute all these in an expression, we have 0.36 Az amperes per meter. So this is for the magnetic field intensity for 0, 0, 4. So now we need to find out the magnetic field intensity H for 0, 0, minus 4. So which is located exactly opposite to 0, 0, 4. Therefore the magnetic field intensity is of 0, 0, minus 4 is, it is minus 36 minus 0.36 Az amperes per meter. Minus 0.36 Az amperes per meter. So in this way we can find out the magnetic field intensities for both 0, 0, 4 and 0, 0, minus 4. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.